which is about solving polynomials that are set equal to 0, or the zeros of polynomials. But let's go ahead and do our long division problem. I've already written it on the board. And we have x plus 3 divided into x cubed minus 2x squared minus 16x minus 2. Now, remember in long division, what did you do? You said, okay, how many goes in here? But it's not quite the same exactly. What we're going to do is simply, in our dividing, look at the x over here and divide the x into the x cubed. And what times x is x cubed? It's x squared. So we're going to put x squared, line it up just like we did in 4th grade or 5th grade or 3rd grade if you're an advanced student, long division. Notice, by the way, if this had been 8x cubed, this would have been 8x squared because this is 1x. Had this been 3.7x cubed, this would have been 3.7x squared because, again, we're dividing by 1x. Now, think back to your elementary school days. After you divided, what did you do? You multiplied. And you multiplied what you had here by what you were dividing by. And now we're going to do that. We're going to multiply the x squared by the x plus 3. Well, x squared times x is x cubed. And x squared times plus 3 is a positive 3x squared. What did you do next? You subtracted. Now we're subtracting polynomials. Remember, in subtracting polynomials, we can either subtract each term, and they are lined up for that purpose, or we can change all the signs in the second polynomial and use our addition rules. I'll do it that way. I'll change this to a minus, since subtracting a positive x cubed is the same as adding a negative x cubed. And I'll change this plus to a minus 2. I like to circle the plus, indicating that I've changed it. And now we can add. Well, of course, this and this will always cancel out, because no matter what, this times this will be the same, that'll be it. So there's no problem there. That's going to zero out. We have a negative 2x squared and a negative 3x squared, which I believe is negative 5x squared. We change the sign, and we are adding. Just in case I make an error, I think we need to have this piece of paper, because sometimes, you can make mistakes, and we don't want you going through a tape with mistakes. Now, what did you do next in your elementary classroom when you were learning to divide? After you subtracted, you brought down the next place value. And the next place value here is negative 16x. Everything is lined up. And after you brought down, you divided. So, we'll divide x into negative 5x squared. Well, 1 times what is negative 5? Negative 5. And x times what is x squared? X times x is x squared. And again, we line up the x with the x in the original problem that we're dividing into. Okay? Now, notice, had this been negative 17x squared, this would have been negative 17x, because this is 1x. No matter what this coefficient here is, it's the same there. The only difference is we've lowered the degree of our monomial. This was x squared, it's x. Over here we started with x cubed, and of course that's x squared. Now, we're going to multiply negative 5x times x plus 3. Negative 5x times x is negative 5x squared. Negative 5x times 3 is negative 15x. Subtract. And again, to subtract, we are going to change the signs in the second polynomial and add. Use our adding rules. So I change these two minuses to pluses. And what do I see? Well, obviously, this cancels out. It has to. Because when we multiply, we knew that this times this would give us this. So when we subtract, we should get 0 there. A negative 16x, a positive 15x, gives us a negative x. And, of course, we do next is to bring down our next place value, which is the ones place, or the constant, negative 2. We divide x into negative x. And what happens there? Well, what times x is negative x? Negative 1. And you'll notice the negative 1, of course, is lined up with the negative 2 in the ones or constant place. Okay, then we multiply. Negative 1 times x plus 3 gives us negative x. And a negative 1 times a positive 3 is negative 3. Okay, looks right. We're going to subtract now. Change the signs and use the adding rules. That cancels out, and we're left with a 1. Since there's nothing left to bring down, that's our remainder. Now, back in 4th grade, you wrote R1 or something like that. But now we know we can write the remainder as a fraction. The remainder over the number we divided by. So we can put plus 1 over x plus 3. So that's our answer. And again, not a very difficult process, but as you can see, sort of long-winded, and it'll be nice if you could do this more quickly using less paper or less chalkboard. And that's what we're aiming to do here. We're aiming to find out about this synthetic division that allows us to do this much more quickly. Okay, let's take a look at the next, or the first visual actually. The first visual is, again, the same thing we just saw. Okay, it's the x plus 3 divided in, and we have the remainder down there. So in case those of you don't like white chalk on green boards, but rather have white on blue visuals, you can see that. In this particular case, what I've done, rather than changing the signs, for those of you who like to simply subtract, I've put the things we subtracted in parentheses with a negative outside. So again, if you don't like the way I did it at the board, go back to this visual, pause, copy it down, and run through it so you can see how it was done. The next visual, in effect, shows you what we've done. So let's take a look at that next visual. We have a division problem, and the answer is x squared minus 5x minus 1 plus a remainder of 1, which means 1 over x plus 3. At the bottom part of the visual, what I have done is replace the x with 10. Just as we checked polynomial addition, subtraction, multiplication, we can check polynomial division by replacing the x with 10. And therefore x cubed is 1,000, minus 200, minus 16 times 10 is minus 160, minus 2 divided by 13. And that's 638 divided by 13, which turns out to be 49 and 1/13. So that's the answer if x is 10. Well, let's look at our answer. Our answer was x squared minus 5x minus 1, which is 100, minus 50, minus 5 tenths, minus 1, which is 49, with the remainder of 1. And 1 over 10 plus 3 is 1/13. So indeed, it checks in both ways, plugging the 10 in to the actual problem and working out the arithmetic, or plugging the 10 into the answer, we get 49 and 1/13. But as I said, this is not the most efficient way to do polynomial division. So what we're going to do is we're going to introduce a new method. And as I've done on a few occasions in previous lessons, I am going to go through the whole thing explaining why it works. If you don't understand it totally, if you don't want to understand it, that's fine with me. But I believe my students should see why methods work. Ultimately, you'll see the method, and the method is a simple method to use, the method of synthetic division. So, what we're going to do is, over here on this part of the board, I'm going to do the synthetic problem just like that problem there. The exact same problem done synthetically. And as I do it, I will go from here to the synthetic problem, showing how they're the same and why the synthetic problem works. Now, you'll notice the first thing we saw is that we had x cubed, x squared, x, and our constant term, and we knew that since this was x, and of course synthetic division, by the way, only works when you're dividing by 1x plus or minus some number. It has to be 1x, and we'll run into a problem later on that will not have a 1x, and we'll see what we do. When I divide x into x cubed, I get x squared. When I divide x into x to the fifth, I get x to the fourth. When I divide x into 2x squared, I get 2x. When I divide x into negative 17x, I get negative 17. In other words, what I get in the answer is always the same coefficient. So when I divide it here into x cubed, I got x squared. the coefficient of 1. When I divide it into negative 5x squared, I got negative 5x, the coefficient of negative 5. When I divide it into negative x, I got negative 1, a coefficient of negative 1. And the degree of the monomial I'm dealing with was 1 less. X cubed became x squared became x, etc., because I'm dividing by x. So we don't need to worry about writing down the x cubes and x squareds. We're just going to write down the coefficient. So let's take the coefficient of the coefficients, I should say, of the number we're dividing into. That is, 1 is the x cubed coefficient, minus 2, minus 16, and minus 2. So we've written down the original problem's coefficients. Okay? Now, let's go back over here and look at x plus 3. We don't need to worry about the x because we know that when we have x squared times x, it's going to give us x cubed. We're going to subtract. It's gone. All we're really concerned about is the plus 3 because that gives us the thing we're going to work with next. We multiply the x squared by 3x, by 3, I'm sorry, x squared by plus 3, got our 3x squared, and subtract it. We subtract it here by changing